Reasonably comfortable?
Yep.
For Jim Campbell, who has Parkinson's disease, it's time to get gooey. Before he can start a computer-based test to monitor his neural activity, dozens of sensors must be activated in this cap using a conductive gel.
Parkinson's disease is not just about one location in the brain that's impaired, it's the whole body. We look at the problems in a very holistic way, combine science and clinical aspects, but with engineering approaches for technology.
With support from the National Science Foundation's Emerging Frontiers of Research and Innovation program, University of California, San Diego bioengineer Gert Kouwenbergs and his team are working to understand how brain circuitry controls how we move. The goal? Develop new technologies to help patients like Campbell navigate the world on their own.
What we'd like to do here is to go one step further and also use technology, advanced technology, but in a means that is more proactive in helping the brain to get around some of its problems, in this case Parkinson's disease, by working with the brain's natural plasticity in wiring connection between neurons in different ways.
Understanding what the patterns are in terms of what's amenable to treatment and what isn't has implications for therapy and rehabilitation for patients and for understanding the nature of these brain circuits that are dysfunctional in the first place.
They're already seeing progress toward making these tests simpler and faster.
This uses Bluetooth for all the data connection.
This new dry EEG cap doesn't need gel or wires, yet is still highly sensitive to brain activity.
Another thing that we're trying to do is get from the sensor level, the level of the little currents that we're recording here on these channels, down to the level of the even much smaller currents inside your brain being generated by neurons.
Using motion capture and virtual reality technology, researchers are learning more about the relationship between neural activity and the human body in motion. That's key to developing devices that will help in day-to-day activities.
It's not about advancing knowledges in an ivory tower, it's about making things work in the real world.
Demystifying how the brain and body work together will lead to a new generation of activity sensors and smarter prosthetics to improve speech and balance. Campbell is glad to contribute.
I get the satisfaction that I'm helping them, and I'm hoping that eventually they'll be able to help me.
Decoding the complexities of the human brain, one of the grand engineering challenges of the 21st century. For Science Nation, I'm Miles O'Brien.